All right, in problem number 44 in chapter 3, lesson 7, in your geometry book, we finally see a proof that you've been assigned that actually is in a two-column proof form where they give the statements and they give the reasons. And so I've copied down what's given is that angle 1 and 2 are complementary. If angle 1 and 2 are complementary, that means they form right angles, correct? So that's going to be a right angle, even though the way I drew it doesn't look so much. I would look in the book at the diagram, but I'm going to use this just to help, kind of reference some things they mention here. So they say in step 1, angle 1 and 2 are complementary. Well, why is that true? Well, the reason that's true is that was given to us. They told us that. And your book has a different way of wording that, but you can just put given because that's usually what you know to be true is that given part, what they list up there. These are the things that were given to be true, and then we've got the diagram, so we see a little bit. They also tell us PB, PC, PD. That just means that ray C is between B and D. Okay. Now, statement 2 says that angle 1 plus angle 2 is equal to what? Well, if angle 1 and 2 are complementary, that means that angle 1 plus angle 2 is equal to 90 degrees. So I'll go ahead and write that down because they didn't fill that in. Why is that true? That's the definition of complementary. Your book may write the whole definition of complementary out, but complementary angles add up to 90 degrees. You can just write definition of complementary there. Now, on the third statement, they say PB, PC, PD. That's this stuff right here that was in the given. So your reason for number 3 is given. Again, you may need to look at the book. It's just that if I try to write the whole proof and all the statements on the iPad, I'm going to run out of room quickly and then have to redraw the figure. So follow along in your book on page 121. All right, so that being said, they then say in statement 4, angle BPD is equal to angle 1 plus angle 2. Let's outline BPD up here in blue. BPD is this angle right here, isn't it? And it is equal to angle 1, angle 2. And so why is that true? Well, that's true because that's the definition of betweenness of rays. So let's just put, that's that whole betweenness of rays theorem. Some books will call that angle addition theorem, but we're gonna use definition of betweenness of rays since that's how our book has talked about it. Now let's go back to statement 5. Statement 5 says angle BPD is equal to 90 degrees. Well, why is that true? Let me write it down since I've got a little room here. Well, that's true because angle 1 plus angle 2 is 90 degrees. We just said in statement 3. In statement 4, that BPD is equal to angle 1 plus angle 2. So since angle 1 plus angle 2 is 90 degrees, and this is equal to angle 1 plus angle 2, by substitution, I can put, and I'll try to write it out here. By substitution, I can put that BPD is 90 degrees since it's equal to angle 1 plus angle 2, and that's equal to 90 degrees. Some books might write there the transitive property. Your book uses substitution, so again, we'll just try to stick with what the book has, but I'll just mention other things you could have written there. Now, angle BPD is a right angle, says number 6. Well, why is that true? That's right, BPD is a right angle. Well, that's true because right angles are equal to 90 degrees. That's just the definition of a right angle. If you're checking it in the key, it'll probably have the whole definition written out. But isn't that what a right angle is 90 degrees? That's how we define it. It has a measure of 90 degrees. So if BPD is a right angle, we're down to the last step of the proof. Now, if it's the last step of the proof, we know that what's supposed to go there, I'm going to circle it in yellow, is what we're trying to prove. So I know, even though it's blank, and this is the last step, I know that I should get this AB perpendicular to PD. That's always the last step in your proof when you're doing these two-column proofs, is what you were trying to prove in the first place, what was listed up above it, the thing they wanted you to actually prove in the proof. And it's AB perpendicular to PD. Why is that true? Well, if BPD, which is that blue angle, is a right angle, then that means the sides that make it are perpendicular. And so if you look and you got a right angle, perpendicular lines form right angles. That was just what we got through saying, is that we had a right angle, so therefore those lines are perpendicular. If you look at Theorem 7 on page 118, it says perpendicular, I'm just going to use some abbreviations here, perpendicular lines form actually four right angles, but we just are talking about this one angle BPD there. But it's still the reason why that's true. That's one of the four right angles there, BPD is. So you've gotten through the proof, and it almost seems like this stuff was almost so obvious that you think, why did I have to take 7 steps to do that? It's because we're trying to not take anything for granted. If we know that angle 1 and 2 are complementary, then we know that they add up to 90 degrees. Therefore, we know that that's a right angle. Therefore, we know that if they're equal to 90 degrees, and if the one thing I didn't put in here, I just might as well add it, was the other part of the given, PB, PC, PD. If that C is between B and D, those rays there are between, then those add up to the same thing, equal to angle 1 plus angle 2. That's how they're just referencing those angles. And they already told us angle 1 plus 2 was 90 degrees, so BPD is also 90 degrees. We can't take it for granted that BPD is angle 1 plus angle 2. We have to actually say that that's true because those rays are between. And then BPD is 90 degrees because angle 1 plus angle 2 is 90 degrees. Therefore, it's a right angle. Therefore, the lines are perpendicular. That's the logic you kind of have to go through here. It's not taking anything for granted and explicitly stating everything that we know about the fact that two angles are complementary.